Welcome back. Let's keep going with our look at compound interest. We talked about future value and present value, and now we're going to put it all together and look at equivalent values. So just like we did with simple interest, we can use the compound interest kind of versions of our future value, present value formulas to help find equivalent values at either later or earlier dates. So if we're, looking at an amount of money and we want to see what it's worth at a later point in time, that would be the future value formula. And if we're looking at an amount of money and we want to bring it back to see what would be worth at an earlier point in time, that would be the present value formula. So we're going to combine those two now, just like we did way back when we were talking about simple interest, to look at equivalent values when we've got multiple amounts on the timeline and that sort of thing. So payment stream, you recall, is just a bunch of payments over time. And if we want to get the combined value of them, we just can't add them up simply because that wouldn't take interest into account, would it? So we have to look at the time value of the individual amounts when we're taking things into account before we add them up. So that really means either adding or discounting interest as appropriate to a common timeline or a common focal date. And to do that, a good timeline is really helpful. So let's have a look again at those sort of key steps for doing a timeline, or the handy dandy steps. First, draw the timeline out. Separate the two payment streams, top and bottom. Typically with these type of problems, we have an original set of payments that was agreed upon, and then we're going to replace those with a new set of payments, something like that. Perhaps one of the early payments was missed, or the person who owes the money has decided they can now pay early, something like that. So we've got two different payment streams, and we want them to be equivalent to each other. You got to identify the focal date. Sometimes you're given a focal date, other times you can just pick one that seems to be easy to work with. Move all of the money, all of the amounts of money to the focal date. Then set up your equation of equivalence. Now, if you've kind of come that far, you've done the hard work. That's really what finance is all about. The last little step is to kind of do the calculations and solve for the unknown value. That's fairly easy once you've done all the setup work. So really concentrate as you're going through these, especially at the beginning, on getting that timeline working for you, right? So that it can help you out. Let's have a look at an example. May is due to make a payment of $1,000 now. Instead, she's negotiated a different deal. So she's going to make two equal payments, 1 year and 2 years from now. So that's an easy example to think about. Somebody is supposed to give you $1,000 today. You catch up to them in the hallway and they say, oh, sorry, I don't have the money. Can I give you two payments instead, one in a year from now and another one 2 years from now? Well, you probably want some interest with that. So we'll work out an interest rate that we think is fair for both parties, in this case 8% compounded quarterly. And with that rate, can we now work out what the new payment should be? So let's have a look. I'm going to start by drawing my timeline. Now, I've got the original deal, or whatever you'd like to call it, up on top, and that was $1,000 now. She wasn't able to pay that, so she's going to replace that with a new set of payments, and the new set of payments are 1 and 2 years. They're equal, so I can call them both X. That's a really important thing. If the payments weren't equal, then we might be in trouble. We need to know either that they're equal or maybe that one is double the other one or something like that. There's got to be some relationship between them. Otherwise, we would be dealing with two variables and we wouldn't know how to do that. So in this case, they're equal. That's great. We've got a rate as well. Let's write that down. I is equal to 0.08. That's compounded quarterly. So that's 2% every 3 months or every quarter. So that's everything we need on the timeline. I'm going to follow the example from the book and make a focal date down here at the beginning. All right. Now you might have easily picked a focal date at 1 year or at 2 years, and that would have been fine. it doesn't really matter with compound interest which focal date you pick. Everything will work out to be the same in the end. So let's go ahead and do the one they picked in the book. So in that case, the original side is just the original side. But the amounts on the bottom, even though they're unknown, they're still dollar amounts. They're going to have to move. This one is coming back 1 year. Now, since we're compounding 4 times a year, that's 4 periods. This one's coming back 2 years, and so that becomes 8 periods. Now we can set up our equation of equivalence where, the original should be equal to the replacement payments. Well, what do we have on the original side? It's just 1,000. On the replacement side, we have that first X being brought back 4 periods, and we have another X being brought back 8 periods. Now, I don't know what X is, but I do know it's an amount of money, so I'll treat it just like any other amount of money, whether I know it or not, and apply my formulas to it. I can start to work out some of these numbers now. This first one is 0.923845. 426. X. Notice I moved the X from the beginning to the end. That's just normally how we write it, isn't it? We usually say something like 3x or 5x, not x3 or x5. So even with a decimal, we'll do the same thing. This is 0.9x. Plus, when we work out the next one, should be a little bit smaller number because it's moving back further. That's 0.853490371x. Now we're doing pretty good. Once we get to that point, we can just add up the numbers on the right side. Really, we're combining like terms. We'd have one number term and a couple x terms. We combine the x terms, we get 1.777335797x. Is it important to keep all the decimals? Absolutely. If we round them off, we could end up with some rounding error in our final answer. So let's keep them all. A great way to do that, by the way, on your calculators is to learn how to use the store and the recall buttons. Those are over on the left-hand side of your calculator, and they let you store numbers and bring them back rather than retyping all the time. That's going to reduce the errors and everything else as we go. So let's come back to our problem. How do I get x now? Well, just divide both sides by 1.773355797, and we get x is equal to $562.64. That's the answer to this one. So May is now going to make a payment of $562 in 1 year and another payment of $562 in 2 years. That'll take care of that 1,000 with any interest that's owing as well. Okay, let's go ahead and give you a chance to try it out. You promised to pay $500 2 months ago and another $1,000 3 months from now. Let's imagine maybe you missed your first payment. Someone's just caught up to you today and said, look, we want all the money today. The money that's overdue plus the money upcoming. And so we're going to make one big single payment today to pay that off. And let's use a rate of 6% to figure this out. Go ahead and hit pause on your player. Try this out. Focus on drawing a good timeline. And when you're ready, hit play and come back and I'll go through it with you. All right, let's have a look. Here's my timeline. Now, 2 months ago, we're supposed to pay $500. So this was the original deal up top here. And we're supposed to pay another $1,000 in 3 months. Here we are today, though, and we're going to replace everything with one big payment. I'll call it X. I'm going to go ahead and make today the focal date. That'll make the work a little bit easier maybe, and that might be a nice intuitive day to pick anyway. And so this is our new payment down here, our replacement payment. We do have a rate as well. I is 0.5% per month. Once I got that focal date, I'm going to have to move everything to my focal date. Let's see, that's moving forward 2 months, so n is going to be 2. And this $1,000 is moving back 3 months. So n will be 3 because everything's working monthly here, isn't it? Now we go ahead and set up our equation of equivalence. The new should take care of the original, shouldn't it? And so that means x, which is everything on the bottom, should be equal to everything on the top. Well, that's 500 carried forward 2 periods plus 1,000 carried back 3 periods. I should say, by the way, don't worry if you picked a different focal date. Your numbers will be a little bit different, your exponents and whatnot, but you should come up with the right answer. And so if we work it all out, add the two numbers together, we get $1,490.16. That's the total amount due today that will take care of those two payments. And if we eyeball it, it seems to be about right, doesn't it? Here we go. That's it for equivalence. Practice a bunch of these from the textbook. Make sure you get the hang of these. These are really critical because they're good, a little bit longer problem-solving questions. They really give you a good chance to work with timelines. And then when you're ready, you'll be set to move on and try our next quiz. Just like always, take your time reading questions. Use a timeline to get organized. That's really key. The better you get at timelines, the better you'll do in the course. Just trust me on that. Keep working with them. Make sure you're able to set up an equation based on your timeline. One little tip, by the way, think about a timeline. We have some stuff on top, maybe, and some stuff on the bottom. Well, the timeline itself becomes the equal sign, doesn't it? Because you want everything on the top to equal everything on the bottom once we picked a common date. So we might have to move things, and we do that by using our formulas. Once we got that, though, top should equal bottom, or bottom should equal top, whatever makes most sense in the question. Once you get an answer, think about it. Does it even make sense? Is it in the ballpark of what you'd expect? That's a good way to spot errors as well. That's it for now. I'll see you next time.